Hey everybody, welcome to our webinar today, Room Heat Pumps, Cooling and Heating in a Small Package. I'm Joe Wachunas with Electrify Now and MBI, here as always with Brian Stewart from Electrify Now. And this webinar is being brought to you by Electrify Now, which is an all-volunteer organization promoting electrification as the quickest path to decarbonization, and that all of us can take an active part in achieving, as well as the San Diego Learn program, which is a workforce education and training program that has partnered with Electrify Now to offer these free efficiency and electrification webinars. Please visit the Learn website for more information, www.sandiegolearn.com. And we've been partnering with San Diego Learn a lot this year to do our Go Electric webinars, talking about the benefits of electrification for homeowners, which include lower energy bills in many cases, cleaner indoor air and less pollution outdoors, more comfort and increased safety. And so today we are talking about room heat pumps. So this technology has had several different names over the years, micro heat pumps and others, but the industry is kind of converging on this nomenclature of room heat pumps. And it's also converging on the level of performance that's available for these room heat pumps. These are, to describe them, they're DIY self-installed products that can heat and cool individual rooms, but they do need ventilation through a window. And so the different categories of room heat pumps thus far, of course, is type 1. We're not going to talk a lot about this. This is AC with electric resistance heat. It's the same, the electric resistance is the same technology that's in your toaster. But we are going to talk, Brian's going to explore in a second, this type 2, AC with heat pump heat. There's a couple different models that are available on the market today, and we're going to be looking into those as well. And our panelist today, Christopher Diamond, will be talking about types 3 and types 4. These are exciting products that are coming to the market relatively soon, and we'll see what's in store and what's on the way.
Great. Okay, so just to kind of cover what you could find today if you're interested in one of these things, these type 2 heat pumps they're referred to, they come in these basically 3 configurations. You'll find ones that are basically window mounted. They look just like air conditioners, but they have the supplemental heating function. There's saddle mounted ones, which interface with your window in a slightly different way. It has some advantages. And then there are what's called portable units that interface, again, slightly differently. We'll go into how these things work a little bit more. If you're actually shopping for one of these, you'll find they're typically called air conditioners with supplemental heat. They're going to range from about $500 to as much as $800, depending on which model you get. And there's obviously promotions, et cetera. But that's what currently, if you went out there and looked, what you would see. These things provide a lot of powerful cooling. And that's often the motivator for people to buy these things, is because they want air conditioning in their rooms or in their apartment. But they also, if you get one of these type 2 units, they provide really powerful heating as well, and dehumidifying, if that's interesting to you. On the heating side, because they have heat pumps, they're twice as efficient as electric resistance heating, which, so if you were to compare this to a space heater, you'd not only be getting, twice as efficient heat, but these also produce a lot more heat. They have a lot higher capacity, 2 or 3 times the kind of BTUs per hour than a space heater would be able to provide. They plug into a standard 120 volt plug, just like your wall, so it makes them fairly easy to install. But the key caveat, and one of the things that's just important to understand about this whole classification of product, is that they are heat pumps, and they work in both directions, heating and cooling. But because they don't have a defrost cycle, these units that are available on the market today are only going to operate when the temperature outside is above 40 degrees or so. So now, that's still, there's still many months of the year that are over 40 degrees, but it's important to understand that you can't rely on these for winter heating if you have temperatures that are below 40 degrees. So let's just talk about these 3 types of products in a little bit more detail. The window mounted ones look super familiar. They sit inside your window opening. They only work with vertically sliding windows. You typically have to screw them into the window frame. That's in order to keep them from falling out. If you, forgot and opened your window, if you slid it open, the unit could tip outside and hurt somebody or destroy the unit. So it has a little bit of, security that way. Some of them may need external supports, but a lot of the new ones don't need that. They just sort of sit on the frame. It means that the window is not operable once you put this in. And because it's a pretty big thing sitting inside your window, it's going to block the view, which is just something to take into consideration. And then all these units have this sealing issue because the unit is typically not exactly the same size as the window opening. So you have these different mechanisms to plug the gaps, but they're thin pieces of plastic typically, which can let in heat or cool air. They often have some little air gaps that are can be problematic. So it's just something important to know that when you put one of these in, you're kind of opening up your window, your building envelope some degree. And we'll talk about this with different configurations, have different kind of pros and cons in that respect. One of the things that's really important, if you're interested in buying one of these, you're buying it online, you have to make sure that you're buying a 120 volt unit versus a 240 volt unit. Unless you've got 240 volts sitting underneath your window, which most people don't have. If you're wiring it in special, then sure, you could do that. But if you're doing a DIY retrofit situation and you mistakenly buy a 240 volt unit, you're not going to be able to plug it in. So make sure you check that. The other thing that's important to check when you're shopping for one of these things is that this difference between the models that have electric resistance heat and the ones that have heat pumps. It's sometimes you have to dig into the details a little bit, but one sure way to know whether you're buying an electric resistance one is to see what kind of BTUs of output it has. If it says 3,500 BTUs per hour, that means it's an electric resistance unit. You want to avoid those. And the heat pump ones are going to be 10,000 or up to 12,000 BTUs per hour, so much more heat output. And that is also an indicator that has a heat pump, because sometimes you just don't say that in the nomenclature, which is maddening. Okay, then there's this other configuration called saddle mounted or saddle back. And this is an interior view on the left and an exterior view on the right. And you can see that it kind of straddles the wall. That has some real advantages because now the window only is opening a couple of inches. That means that there's no permanent fixtures required because it's basically balancing on your window frame. You can see there's these adjustment mechanisms here to make it fit. Now, you do have to make sure that your walls aren't too thick, because if you have really thick walls, like sometimes some masonry clad buildings, et cetera, might not work because they'll have some limitations that will be stated on the device in terms of how thick your walls can be. But it has the advantages that now you've got this really small window sealing areas, and sometimes they'll come with nice foam blocks that really essentially eliminate the sealing problem that the window air conditioners have, which is nice. And also now you can still open your windows if you want to. You can see out your windows because you really haven't taken up any space. So these things are pretty slick, I have to say. They're also potentially quieter because now, the condenser unit, which is the thing that makes the most noise, is on the outside. Of course, you've got a fan inside, which is going to make some noise, but typically these things should be quieter than the window mounted units. And then the third configuration is called portable. And these are, in this case, the whole unit is inside your home. This can be an advantage in some situations, like, for example, some kind of rental units don't allow those window units because they're worried about them falling out and hurting people, et cetera. So sometimes there's rules that prevent you from using those. These don't have that problem because the whole unit is inside. They're also typically easier to install because really all you're doing is you wheel this thing into your room, plug it in, and then you have to install the window kit, but it's typically simpler. They can work with windows that slide vertically as well as horizontally. They do have this large ceiling area problem that, again, we talked about earlier. Now you've got, this is typically a thin piece of plastic that's filling up the gap between the bottom of the window and allowing space for these pipes to go out, the hoses to go out that communicate with the air outside, because all of these units, how they're working is they're harvesting energy from outside your home and delivering that inside. So you can see there's window kits that come that are relatively straightforward to put together that plug those holes. We really recommend you get a unit that has 2 hoses, these dual hose models. And the reason for that is if you have a single hose model, you're creating this pressure difference in your home. You're blowing air out of your home. That means air is getting sucked in your home somewhere else. And that's going to be unconditioned air that you're bringing in, which basically counteracts the efficiency of the product to some degree. So in general, the dual hose ones are going to be more efficient and not have that air infiltration problem. So look for a dual hose model. We also recommend highly that you make sure that the units you get have an onboard drain pump, because an air conditioner or a heat pump is going to create some condensation. If the condenser is on the outside, like it is with a window unit or the Saddleback ones, that's not so much of a problem. It might drip a little bit outside your home. But if it's inside your home, it's creating water inside your house. You have to drain it essentially somehow. So if it has an onboard drain pump, it's easy to do. You can run a little hose out your window or drain it into a bucket or something like that. If it doesn't, you've got to like unscrew this little cap and figure out how to get a container underneath there. A real pain in the butt, if you ask me. So I would not buy one if it didn't have an onboard drain pump. And so the models we'll show you here are all models that have that feature. Okay, so this is just an overview of what's out there. I'm not going to go through this in a lot of detail. This whole kind of chart here is available on our website. We'll put the link in the chat. But from a window mounted standpoint, there are 4 models that I could find that are available today that range in price from about $500 to $650. You can see they're very comparable in terms of performance, except for this one Keystone model, which is smaller in terms of its cooling and heating output. You will see that there are the numbers that kind of refer to performance are what it's cooling BTUs per hour. So that's how much cooling it can put out, cooling energy, how much heating energy it can put out. And then there's a cooling efficiency rating that these things all have. And you can see that if it's over 12, I think we just discovered today, it should have an Energy Star rating for cooling only, which is helpful if you're using it for air conditioning. So, but otherwise, these models are pretty comparable in terms of their performance. Then the saddle mounted versions, there's really only one that I think is worth considering at the moment. It's this Soleus. They have 2 sizes of it that vary from room size of about 475 square feet up to 550, and about $100 in difference in price. They're quite efficient from a SEER rating and have good heating output, and they're reasonable cost. There is another model from Gradient that does basically this exact same in terms of performance, but it costs over $2,000. So I didn't include it here, but just to know it's out there. We'll talk more about Gradient and some of the cool things they're doing in just a minute. And then on the portable side, there's 3 that I would recommend that are dual hose units that also have onboard heat drain pumps. And you can see they're a little bit more expensive. They range again from $500 to almost $700. They have a range in efficiency differences. This Medea Duo is the one that always comes out on top in terms of efficiency and recommendations. It has a lot of features. It's one of the quietest ones, so it's hard not to recommend it. This Cooper Hunter model looks to me like a Medea takedown. It might actually be made by Medea because Medea makes a lot of products for other brands, and it's very similar. But these are the options that you have out there that have these features that we recommend for dual hose and a drain pump. Okay, so that's basically what's out there today. And this is a good opportunity to introduce our guest panelists today. We have Christopher Diamond with us from Northwest Energy Efficiency Alliance. We call it NEA here for short. He's a senior product manager there. We've had him on many of our webinars in the past. He's a co-founder of the Advanced Heat Pump Coalition. So he's kind of our heat pump guru, so to speak. And his research focuses on particularly these variable speed heat pump technologies, the really most efficient ones for space heating and cooling. And he's got all the qualifications you would want for in terms of engineering and engineering science and building science, and over 25 years of experience in this area, which is why we love having him on our program. Welcome, Christopher. It's nice to see you again.
Yeah, thanks, Brian. Thanks, Joe.
And yeah, I'm just going to stop sharing here, and we're going to do a little Q&A with Christopher. And maybe Christopher, you could just
Yeah, let me just give
fill
you a
in the
quick
blanks
little.
on NIA and what NIA is and what you do there, beyond your bio.
So, yeah, the Northwest Energy Efficiency Alliance is a nonprofit funded by the gas and electric utilities of the four Northwest states, Idaho, Montana, Oregon, and Washington. And the work we do is really parallel to what the utilities do in terms of their programs, but we work more upstream with the market actors like the manufacturers, the distributors, trying to remove barriers to new product development. And for this class of product, when we start talking about heat pumps, one of the things that really is a key first step is how do you know which one works well? And so it's about performance ratings. And we're still going through this initial steps of getting a test procedure established so you can rate a room heat pump on its heating efficiency, not just its cooling efficiency.
Yeah.
And that's kind of the core thing. I've been following this stuff for about 5 years, and I think we finally are at the edge of seeing some products in the market that are a whole different class of product, and we'll talk about that.
Yeah, I'm excited to talk about that. I mean, I think this whole zone is really seductive because I think anybody who's, shopped for a heat pump, if you've got putting in even a mini split system, you're talking about thousands and thousands of dollars. And if you're talking about central heat pump system, it could be, you're talking in the range of 20 grand, depending how big a one you're getting. So these smaller units that are lower cost are really interesting and seductive as a product classification, which is why I think we get so much interest from people about them. So that's why it's important to understand, what the limitations of the ones that are available now, and we're going to talk about some of these really exciting things that are on the horizon. But maybe before we get started in talking about the new ones, I want to I know you guys have done a lot of testing on these type 2, what we're calling type 2 heat pumps.
Mm-hmm.
Give us a little overview of what you learned from your tests and what that means in terms of how you would recommend or not somebody buying one of these.
Oh yeah, about a year and a half ago, we did what's called a home use test of about a dozen machines just to see how do people interact with them. What do they think of them? Because they're basically classic room air conditioners that also heat. And that's mechanically pretty simple. You're just reversing the heat flow. It's a valve fundamentally and a little bit of controls. And one of the things I would say we found was that people are principally thinking of them as room coolers, room air conditioners, and the setting that you have on these can be heat, cool, or auto. And when people left it in auto mode, we found that there wasn't very effective heating or cooling. These systems tended to flip back and forth because you might have other heat sources or things in your room. So if you're going to do heating, do heating. If you're doing cooling, do cooling. Don't set it to auto. That's kind of a no-no in terms of getting what you paid for.
That's a good piece of advice, Christopher. Always avoid auto. I mean, I think ductless heat pumps have an auto setting too, so that's a good takeaway from this.
Yeah, you guys are smart enough to know when you need heating and when you need cooling. Let's see. The other thing was just sort of like physically knowing what your window is capable of holding and handling in terms of physical size. Do you have anything on the outside of the building or inside of the space that it might interfere with? That's especially true with those portables. They're not small. They're 100-pound, like an R2-D2, and you got to figure out how you're going to hook it to a hose to your window. A lot of people get confused between that vertical sliding, what's called a sash window, versus a slider, which is the more classic sort of apartment window that has this horizontal sliding mechanism. Some of the other window configurations, your casement awning types, really don't have a solution right now. But I think that over the next decade, we're going to see a lot of variations into what I call micro heat pumps of all kinds, little sizes, different configurations, mechanical design. But for that to happen, we have to have the next generation be successful and find its niche so that manufacturers continue to explore and develop different variations for more custom applications.
Yeah. So Christopher, one of the things when I was doing this research and to put that chart together and stuff, one of the things I found confusing was that, there's this SEER energy efficiency rating that these units will have, which is for cooling, which is
Mhm.
helpful, of course. But there was very little information about the heating efficiency of these units. And so talk about the testing a little bit and just the
Sure.
kind of like information that's helpful to consumers when they're looking at these things.
So the federal minimum for cooling is basically 10.9. You have to have a CER value of 10.9 or better, and Energy Star is mostly in about the 12 range. And this just reflects, its relative efficiency under a certain test condition, a fixed test condition. And that's very true for those classic cheap room air conditioners that have one speed and they're a little noisy. Now we're getting into variable speed products, so they can actually operate more efficiently at part load, and we still don't have metrics for that. But I want to point out these next generation of heat pumps are going to be a lot quieter as a consequence. They're not just as loud, and like Brian pointed out, that sort of saddlebag, or some of them are even a U-shaped configuration, can potentially be a lot quieter in the room, which is an advantage.
Yeah.
But we do need a heating rating, and DOE and EPA have developed a rating that machines are now being tested to, and products for this next generation of Type 3 and 4 are going to become available in Q4 and Q1 of next year.
Well, maybe that's a good segue here. Let's bring back this chart here that we used at the beginning, and just as a segue into the products that are coming. So remember, we had this chart of Type 1, Type 2, Type 3. So we agreed we're kind of dismissive of Type 1, but Type 2 has some interesting use cases we just talked about, but it has this kind of dramatic limitation at 40 degrees where it just won't work when the temperature's out below 40 degrees. Tell us a little bit about this Type 3 and Type 4 and what it means for these, and what's different about these machines that makes them operate in a wider temperature range.
Yeah, once you get down to outdoor temperature about 40 degrees, you're trying to pull heat out of that air. You have to have the outdoor coil be colder than 40 so the heat flows into the coil. That outdoor coil can be 30 degrees, and suddenly frost and ice will start packing up on the outside. That's the difference really between Type 1 and 2 and Type 3 and 4. Type 3 and 4, they can deal with the frost. They can defrost. And so they go through a cycle in which they eliminate the built-up ice on the outside. And this is, like a technological shift. It's the creation of the ability to deal with frost. And with window units, one of the key criteria is you don't want to just have this icy cold water dribbling down the side of your house, down onto the sidewalk. You had to have some way of dealing with it. So what the manufacturers of Types 3 and 4 have developed are a mechanism getting rid of that melt water, that condensate water, in a way that atomizes the water and sprays it out as an extremely fine spray of water, just more like a fog, if you will. And it disperses and is absorbed by the outdoor air. So when that defrost cycle comes on for Type 3 and 4, it's not going to build up liquid ice on the outside or clog things. It's going to get rid of that. And that is a big shift and a technological evolution, actually.
Well, and tell what's the state of these products? I mean, that seems like a hugely important thing, atomizing the water. But when we've been hearing about them for a little while, when will we see them hit the market? And any ideas on cost? What are they going to cost compared to the existing Type 2 room heat pumps?
Yeah, so the two manufacturers that are bringing products to market were spurred on by a New York State challenge in which they said, we'll buy 30,000 of these things if you'll build them to be cold climate, really super capable. And so both of them are coming out as being very, very sort of large, physically large in terms of heating capacity when it's really cold, other capabilities. So they're only Type 4s that are hitting the market immediately. And they're built by Midea and a company called Gradient. Both real innovative, both saddlebag design. I think we got a slide here.
Yeah, should we go to that?
Yeah, so this is the outdoor side of the Midea PWHP. And I drew a little arrow here to show there's a little port where this atomizer will allow the meltwater and condensate to be atomized. So you don't have to worry about water building up on the inside of your house. You don't have to worry about ice building up on the outside. Key innovation. And if you see the operating range of this thing can go down to minus 13 degrees Fahrenheit. It's quite capable,
That's
delivering pretty solid performance. It is in fact a cold climate mini split heat pump that's been packaged into a shape and form factor that you can slide out through your window. This thing is like 26 inches wide though, so it's pretty big, and it weighs 120, 130 pounds. Yeah, so it's a two-person install, but it's a 15-minute install. NYSERDA's installed many of these already. That's the New York State Energy Research Authority, NYSERDA, NYCHA, the New York Collaborative, and some pretty aggressive developments going on there, because they had
I
all these.
saw a pretty cool, there's a YouTube video. You can, if you Google Medea cold climate window heat pump, or something like that, you'll find it of how it installs. It's really slick the way they've engineered this thing it still takes two people. They recommend two people, but it's kind of like a slide in thing and then it folds
Yeah.
down. It's really cool.
No permit required. Plug it into an outlet. I will say though, it's going to draw a lot of that circuit, whatever it's on. It's going to draw quite a bit of the power on that circuit. So you can't have, your toaster or your hair dryer or your microwave on the same circuit. Lighting is fine, probably computers and such are fine, but really big loads like those, things like a hair dryer probably would trip the breaker if you had it on at the same time this thing was running at the same time.
Yeah, it's interesting. I mean,
Go-
those units we were looking at, they topped out at about 13 and a half SEER for cooling efficiency. This is 16, so it's much more efficient on the cooling side. And then this is really interesting, this coefficient of performance, which basically is saying, how much heat it's providing energy versus a unit of energy, electricity. And you can see that it depends on what the temperature outside is, right? And that's why this heating efficiency thing always seems like a tough one to nail down, because it changes as the outdoor temperature changes, right?
Yeah, and the COP value, for those of you on the line, is very similar to the same number we give for electric resistance. Electric resistance, the COP is 1.00. So even at its very coldest, it's still delivering 40%, 41% more heat at minus 13 Fahrenheit than your electric heater. And it's delivering 4 times as much heat per unit of energy you buy. So you buy one unit of energy, you get 4 moved from the outside to the inside. And that's impressive.
Yeah.
We're now talking about a whole class of product that's notably high performance. The sound levels on the inside at its low operating condition are well below kind of what you're going to hear. 26 dB is just super quiet.
Yeah.
Go to the next slide. And let's take a look at the other one, as it shows the indoor one. And this is the Gradient all-weather unit that they're releasing. I think it's in very limited quantity in Q4 and probably not really widely available until next year. Similar performance numbers, similar noise levels. This is the inside picture of it. It's very aesthetic. It's got a cool interface. And there's if you go to the Gradient website, there's some great little videos to show you how it slides in and articulates around the window. And like I said, it's a pretty quick install.
Very similar numbers here, it looks like, in terms of performance.
Yeah, the price of these things are, I think, on the order 3 to 4 grand.
And so, Carson, compare that to like a ductless heat pump. What are maybe that would be the biggest competitor for these. What are folks looking at when they're getting a ductless heat pump versus these saddle mounted all-weather heat pumps?
Right. So with a ductless heat pump, you have to have it professionally installed, and you're probably looking at $4,500 to $6,500. So they're definitely less expensive with very similar performance characteristics. A ductless heat pump. of course, you have an indoor head. The indoor unit can be placed high on the wall, or you can place it different ways. You have to run refrigerant lines through your walls. It's a little more invasive, but
And
it's a
in
little
terms
more
of
flexible.
this heating capacity, how would I know mini splits come in a lot of different sizes, but I mean, what like a smallish one, how many BTUs per hour is it going to be delivering
Yeah, these
versus
are small. 9,000 BTUs is more than enough to heat any single room in your house. Um, and for 120 volt mini split, it's probably like a 9,000 for cold climate and maybe 12,000 for a not cold climate.
Okay.
And you can kind of think of these are essentially like a 12,000 BTU unit. You don't need 12,000 BTUs when it's 47 degrees out. You probably don't need that much heat. What you really need is you need the heat when it gets cold, and you need a way of getting rid of the moisture. And so that's the key differentiator. They're all using new refrigerants, the A2L refrigerants, which have substantially lower GWP and lower volume of refrigerant within them. They're virtually a completely packaged unit, so there's hardly any refrigerant in these guys.
Yeah. Let's talk about the testing and tax credits and all that kind of stuff, because that's the other thing that people are curious about. Like these things, now you're spending maybe $3,000 for one of these things. You're installing yourself. That's great. Could you potentially get a little help from the feds to lower the costs?
Yeah, so under the Inflation Reduction Act, there's a tax credit criteria called 25C, and that's going to provide a 30% tax credit up to $2,000. So most of these will come, you'll get $1,000 tax credit off of these once we have the specification for what the criteria has to be and a test procedure to test to it. And the final versions are due out anytime. I know that the two manufacturers are currently testing to the proposed test procedure, like literally this week. So it's going to happen, but I can't say definitively exactly when. The
Right.
heating season performance, that would be the HEER ratio, the here. There was a SEER and there's a here. So the heating energy efficiency ratio values will probably be north of 10, but we don't know for certain here.
Okay.
And these are the tier 4. They're the really big, heavy duty, can handle a lot of heating. If you're in an apartment building, this is probably all you need for the entire space. The problem becomes in an apartment building, you might have multiple rooms, and getting the air to move between rooms means you got to leave doors open. So there's some limitations with that. You might still have a back bedroom with a small little space heater or something, but the primary living room, kitchen room, dining room in an apartment building, certainly. In a house, it's so dependent on the layout of the house and kind of general room, but you can think of, 500 to 800 square feet viable.
In most climates. And Christopher, real quick before we look to the future, I just wanted to make sure I understood on those type 2 heat pumps that you saw, not the colder climate ones. Do you see people, in your studies, did you see folks using those heat pumps during like shoulder seasons and then taking them out in the winter? Or how are they using them for heating purposes?
Yeah, we didn't follow on to see what they did with them for the summer. My assumption would be that you would leave them in year round. Um, the portables, if you're just using it primarily for air conditioning, um, maybe maybe seasonally move it around. Maybe you move it from room to room. Um, I don't really have a really clear picture on that. The when you look at the amount of energy we use for heating compared to cooling, heating is a bigger deal for virtually all climates in the U.S. Even down in Kentucky or even in Alabama, there's a lot of heating hours in the sort of mild climate conditions, and that's typically in that sort of you want to be able to get down below 40 degrees, in my opinion. But if you're living in Florida, maybe you just heating down to 40 degrees is fine. It's very rarely below 40 in Florida or Alabama or Louisiana. But most
Yes.
everywhere else in the country, you're going to go below 40 degrees.
Right, which is why this type 3, so just to be clear, the ones that are coming are type 4, that New York,
Mhm.
wanted them to get down to really low temperature, so they would for sure work year round as a cold climate heat pump. Then this type 3 are a more mild climate, maybe they heat down to 17 degrees or something like that. I guess, what
Yeah,
do
no,
we
I think
about, what do
I
we know
think the
about
next
that?
I think the next, if these are successful into the initial foray with these Type 4s, I think we'll see some Type 3s maybe kind of built on that same kind of U-shaped design where the window slides down between the indoor and outdoor. That's a
Mhm.
pretty interesting design. Smaller capacity, but potentially serving a really sweet spot for like a California home where getting down to 17 degrees is all you ever need. Here in the Northwest, we have a large part of our population lives in a marine kind of mild climate. There are lots of climates throughout the U.S. where getting down to 17 degrees is going to take care of almost everything. I think it's important to point out that with these window type heat pumps, I think it's pretty safe to say that there is going to be some other kind of heating system in the house. And so what they're doing is they're displacing the more expensive heat of electric resistance, or maybe they're displacing some natural gas usage. They're not replacements. They're there to displace something with a more efficient solution, potentially give you more control over that particular space you're putting it in.
Right. Well, anything as you're looking in your crystal ball, do you see for the next 5 years, do you see prices coming down? Do you see a lot of new products coming out? What do you see?
I don't have that level of crystal ball. I know that what I'm doing with the manufacturers is encouraging them to be successful with this one, and they're already thinking about their next generation designs. But from a business perspective, they're trying to see like, was our first foray successful? There's a couple of questions in the chat around filtration. They're all going to have some level of filtration, just to
But
protect
probably
the
not
coils.
great. Wouldn't you think that most likely the
No,
filtration from these probably not going to be like you can get on a
not
central
an
heat
air
pump system?
purifier, right?
Yeah.
No,
Yeah.
they'll be the same as a central air, as an air or a window, or I mean, or mini split. They're not
A
going to
mini
be
split,
air.
but
They're
not
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 going to
not like a
be
central system where you can put a nice 4-inch filter on it or something like that. You're not going to get that.
true enough. Yeah.
Yeah.
I mean, the filtration that they put on these things is to protect the coils from getting clogged.
It's not to
It's
protect
not a,
your lungs.
it's
It's
not an
it's to
air
protect the unit. Yeah. So,
purification.
but on the other hand, I always think like the use cases for these are, like an apartment or something like that for $100 to maybe $300 maximum. You can get really good air purifier to take care of the air filtration problem as a separate thing. So I don't get too hung up on the air filtration thing with these, but it is true. You just should know they're not going to really clean your air.
Yeah. Um, there's some other questions. I'm kind of scrolling through here and looking at a couple of these. They're currently using A2L refrigerants, not R290, which is propane. We still have some ways to go before federal. It's really about rules, regulations around safety can start using propane as refrigerant. But I anticipate that'll happen in sometime in the next decade. Um, and let's see here. They're 120 pounds to bring two people.
But still DIY. It doesn't. You don't have to get
Yep.
a specialized contractor to install these. Yeah.
No, they're pretty cool. I've installed and uninstalled the one unit we bought. I don't know how many dozens of times, just as a
There was
demo.
a question about through the wall versus window, and these new units that we were talking about, these cold climate ones are window mounted ones. I don't think there's a through the wall option there, but some of the
Yeah,
window air conditioners, the type 2 that I mentioned in the chart there, the ones that look like window air conditioners but have a reverse cycle so they can heat. Many of those can be used as through the wall. Also, we have one in our home that's through the wall like that. So that is possible, but not the window oriented ones. Yeah, the side
yeah,
ones, for example, won't work through the
and
wall.
we're really not going to see the portables being able to be cold climate, type 3 and 4 likely, just because of moisture and because that just having to move all that air through that little hose is a huge restriction, and that's why their performance is relatively low, substantially lower than Energy Star. But they just fill a specific market need, which is I want to have it hook up to a different type of window, or I've got a need for portability.
Yep.
Great.
Great. Well, Joe, any last questions here?
No, I think we've covered a lot in 40 minutes, Christopher. So really appreciate your time,
Sure.
and yeah, excited about what's to come with these room heat pumps.
Very
Yeah,
exciting.
I'm hoping that we're going to see some horizontal slider variants in the next couple years, and that'll open a whole range of applications for people with more apartment style windows that are typically the slider type.
Yeah.
Great.
Excited.
Well, thanks, Christopher, and thanks to everyone in the audience for joining us today. And if you have any questions about electrification, reach out to Joe or I. We're happy to help. And Joe, any final thoughts?
No, just good luck with your electrification projects, and let us know how your room heat pump adventures go.
Thank you.
Thanks all.
All right. Thanks, guys.